Welcome to Writing Better Code with Reactor 3, Part 1, a Code You Can Use screencast. Reactor 3, or more generally, reactive programming, is one of the key changes introduced in Spring Framework 5 and Spring Boot 2. This reactive capability is built upon Project Reactor, which is a Java 8 implementation of the Reactive Streams specifications. So what are reactive streams and why do we need reactive programming? Reactive streams are designed for asynchronous processing of live data streams, which often have data volumes that cannot be predetermined. This is a common pattern, especially for large scalable application services. The reactive streams specify a non-blocking, event-driven programming paradigm with a back pressure mechanism for controlling data flow. This simplifies implementation of efficient, responsive, scalable, and resilient systems with decoupled components. In reactive streams, a publisher is a source of data and a subscriber is a consumer of the data. A subscription connects the publisher and the subscriber, and there can also be any number of processors or processing modules along the subscription. Let's write some code to explore reactive programming with Reactor 3. We start with an empty Maven project. In the pom.xml, we first set up the Java version to Java 8 or higher. This is because Maven defaults to Java 5 and Reactor requires at least Java 8. Next, let's specify the dependencies. While we can specify the versions individually, let's use the dependency management provided by the bill of material for consistency. The latest release BOM is Dysprosium SR7 version, which we'll use. We'll include the reactor call for call reactor 3 functionality, and for testing, we'll use Unit Jupyter API from JUnit 5 and Reactor Test. Let's now create a test class to explore the core functionalities of Reactor 3. The primary publisher in Reactor is the flux, which represents an asynchronous stream of 0 to any number of data elements. A mono is a specialized simplified version of publisher that represents a stream of at most one data element. In a Spring application, a data stream typically originates from some request or response. For instance, the Spring data interfaces of the R2DBC and the reactive NoSQL databases and the web client interfaces return flux and mono data streams. For this demo, we use the mono and flux factory methods for generating static data streams. The just factory method generates a mono or a flux from the parameters. So mono.just1 generates a mono of an integer, value of 1. We'll add a log method to observe the mono and run it. We see that nothing happens. Now let's add a subscribe, and when we run the test this time, you can see that there are a number of events recorded in the log. Let's trace the sequence of events. First, subscribe is called on the publisher. The publisher in turn calls on subscribe on the subscriber, sending it a subscription parameter. The subscriber then calls request on the subscription to start the data flow. Subscribers on next is called with each data element, and then on complete is called at the end of the data stream. Remember that a mono can only have at most one data element, so we cannot specify more than one. Instead, we can use flux.just1, 2, 3 to generate an integer flux of 3 data elements, 1, 2, and 3. Let's now subscribe to the flux and observe the event log. We'll see the same sequence with an on next with each of the data element, and then on complete at the end. Besides observing the events through the log, we can also intercept and process each event in the data stream. We can intercept the onSubscribe event with doOnSubscribe and print it out or capture the subscription in a field for later use. We can intercept the request event with doOnRequest and examine the request parameter. Perhaps more useful, we can intercept the data elements with doOnNext. Similarly, we can capture the completion event with doOnComplete. There are a few other similar methods for intercepting other types of events, which we'll ignore for now. We can also specify the behaviors in the subscriber instead of using these methods. The first optional parameter of subscribe is the data element consumer. Let's comment out doOnNext and copy the behavior to subscribe. As you can see, this gives the same output. Next optional parameter to subscribe is the error consumer. Besides onNext and onComplete, there's also onError that's called when an error occurs in the data stream. To illustrate this, let us create an error using flux.error method. When we run the subscription on this, we can see that onError is called when the error is in the data stream. The data stream is stopped whenever an error event occurs. Again, we can move the behavior from doOnError to subscribe. The third optional parameter of subscribe is the onComplete runnable. Moving the behavior from doOnComplete, we can see the behavior is unchanged. The last optional parameter to the subscribe method is the onSubscribe consumer. This option is seldom necessary and should be used with care. If I just move the doOnSubscribe behavior here, you'll find the data stream does not start. This is because the request call is missing. You are expected to call request on the subscription to start the data stream. In the default scenario, request is called with long.max value, which indicates request for as many elements as there are in the flux. We can also apply back pressure by indicating the maximum items the subscriber is prepared to accept next. Let's say we only have capacity for processing the data elements one at a time. Then the request would be for one element. And the next request is called only when capacity is freed up. You can also specify a subscriber instance that includes all these behaviors. We'll examine that in a later demo. Besides integers, we can also create monos and fluxes of other types. We can create publishers of longs, strings, objects, lists, maps, and other publishers. Besides using the just factory method, we can also generate ranges, flux from iterables such as lists, from streams, and from arrays. We can also generate an infinite sequence of long values incrementally from 0 using the interval method from flux. We specify a duration that's the interval between each data element. This sequence is infinite and does not complete. The application does not wait for the flux to complete before exiting. So to observe the flux, we'll have to delay the termination by using something like thread.sleep. We can use the cancel method on the subscription to end the flux when under certain conditions. For example, in this case, we might want the sequence to be cancelled when we receive any item that's greater than 10. As with other events, we can also intercept this cancel event and print it out or take certain actions. That ends part 1 of this tutorial. If you find this useful, like, share, or subscribe so that more people can find it. Thanks for watching. Happy coding!